The two-sum problem asks us to find two numbers in an array that adds up to a specific target. We are given an array of integer nums and an integer target. Our task is to return indices of the two numbers that, when we add up together, equals to the target value. It's important to know that the problem guarantees exactly one solution, and we cannot use the same element twice. We also need to ensure our solution is efficient and we don't fall into the trap of checking every possible pair, which could lead to a quadratic time complexity. The approach I have chosen to implement involves a single pass through the array, using hash map to store and check for the complement of each element. The complement is what we need to add to the current element to reach to that target. Let's dive into the code. We start by initializing an empty hash map called scene, which will store the value of each element as key and its indices as value. We then loop over the array nums, using enumerate to get both the indexes I and the value n of each element. For each element, we calculate its complement, which is the target minus the current number n. If the complement is already a key in our scene hash map, it means we have found two numbers that adds up to the target. The current index I and the stored index scene comp are two indices we want to return. If we don't find a complement in our hash map, we add the current number n and its index I to the scene, so we can look it up quickly as we're counting through the array. If we go through the entire array without finding a pair that adds up to the target, which won't happen this problem, since a solution is guaranteed, we will return an empty list. For instance, if our input is 2, 7, 11, 15, our target is 9. When we reach out to the number 7, we've seen that 2 has already been seen, and 2 plus 7 equals to our target 9. We return the indices 0, which represent 2, indices 1, which represents 7. Then add up, it's the target 9. This solution provides an efficient way to solve the two-sum problem. The time complexity of this solution is O of n because we traverse the list containing n of element only once. Each lookup in the table costs only big O of at one time. Big O of one time. The space complexity is also big O of n. Since the worst case scenario, we need to insert all elements into the hash map.